Good afternoon, everyone. Myself, Dhanasekhar, Department of CSE, Shriram Engineering College. Today, I discussed about Introduction to Compiler. The topics to be covered: translator, analysis, synthesis, model of compilation, phase of compiler, difference between compiler and interpreter, types of compiler, and the last one, context of compiler. That means cousins of compiler. Translator. A translator is a program that take one form of program and convert into another form of program. Why do we need this? Because human write in high level language like C, C++ or Python, but machine understand only binary codes and zeros, one and ones. There are three main types of translator: compiler, interpreter, assembler. Compiler to translate the entire program at once into machine code. Interpreter to translate line by line. Assembler, it convert assembly language into machine instruction. Compiler. The compiler read the entire program written in high level language and produce a target program in machine code. It is faster during execution because once compiled, the program is ready to run multiple times without translation. In this slide, so we have an example. In the variable a and b are declared in integer and c equal to a plus b, the print value to print the C value. This is our source program. The compiler to take this source program entirely and convert into the equivalent target program that is called machine code. An interpreter. And the interpreter is also program that read a program written in source language and translated into an equivalent program in target language. Now they compare with an interpreter. The interpreter execute the program line by line. Assembler. Then next the assembler. This is simpler than compiler or interpreter. It works between assembly language and machine language. Assembly language use machine codes like move, add, mul, multiplication, and the assembler convert these into binary code. Next one, analysis, synthesis, model of compilation. The compilation process is divided into two parts: analysis and synthesis. Analysis phase, so break the program into small pieces of program that generated an intermediate representation. Synthesis phase, take the intermediate representation and produce the final machine code. In analysis phase consists of three subphases in compiler design. The first one, lexical analysis, second, syntax analysis, and third one, semantic analysis. In synthesis phase consists of the following subphases: code optimization and final code generation. And next, the very important topics in compiler design, the phase of compiler. So we are going to carefully walk through the phase of compiler. So in phase of compiler, we have 6 different phases. The first 3 phases is called analysis phase, and last 2 phases is called synthesis phase, that is called code optimization and code generation. Remember, a compiler is not a single program that instantly turn high-level code into machine code. Instead of structured pipeline with multiple well-defined phases, each solving a specific part of problem. The phases can be grouped into 2 categories. Phases of compiler. Today we are going to carefully walk through the phase of compiler. This is a very important topic in compiler design. Remember, a compiler is not a single program that instantly take a high-level code into machine code. Instead, it is a structured pipeline with multiple well-defined phases. Each phases to solving a specific part of program. The phases can be grouped into two categories. The first one, analysis part, that is called front end of the compiler, that take understanding the source program. Second phase, synthesis phase, that is called back end of compiler, to generating efficient target code, that is called machine code. So in compiler, we have a total 6 different phases. The first 3 phases called analysis phase, called lexical analysis, syntax analysis, semantic analysis. These 3 phases is called analysis phase. The last 2 phases, code optimization, code generation, is called synthesis phase. Next, the lexical analysis. The first phase of compiler design, lexical analysis, is also called linear analysis or scanning. This phase to read the source program character by character and convert into a sequence of tokens. Tokens are the smallest meaningful unit, such as keywords, identifier, operators, and constant. For example, consider the following statement: position equal to initial plus rate into 16. This statement is breaks into tokens. The tokens are position, initial, rate. These are all identifiers. Then assignment statement, arithmetic operations like plus, multiplication symbol, addition symbol, and numerical constant. These symbols are converted into tokens. This process remove white space, comments, and ignore formatting. The output is a stream of token stored into symbol table. At the end of lexical analysis, the source program is converted into tokens. The tokens are stored into symbol table for future reference. And second one, the second phase is called syntax analysis. Once tokens are identified in lexical analysis, the compiler check their structural arrangement in the syntax analysis phase. The another name is called parsing or hierarchical analysis. The syntax analyzer or parser verify that the program follows the grammar rules of the language. If the sequence of tokens does not conform to grammar, the syntax errors are raised. So in this slide, in lexical analysis, to create 3 identifiers and 1 constant. These identifiers and constants are generated in parse tree as like as id into 60. This value is added to id2 and this value is assigned to id1. This is a syntax tree. And next phase is a semantic analysis. Semantic analysis which ensure that the program is meaningful. Even if a syntax is correct, semantics may be fail. This phase check the type, compatibility, scope of variables, and proper usage of identifiers. So it performs following operations: matching of parentheses in expression, matching of if-else statement, performing arithmetic operations that are type compatibility, checking the scope of operations. Syntax analysis is also called a parsing or hierarchical analysis. Once the tokens are identified in lexical analysis, the compiler checks their structure arrangement in the syntax analysis. The syntax analyzer or parser to verify that the program follow the grammar rules of language. If the sequence of tokens does not conform to grammar, syntax errors are raised. So in this slide, so the lexical analyzer to create the stream of tokens called id1 equal to id2 plus id3 into 60. This stream of tokens is converted into parse tree like this. And next we move to semantic analysis. The semantic analysis to which ensure that the program is meaningful. Even if syntax is correct, semantic may fail. This phase check the type compatibility, scope of variable, and proper usage of identifiers. The semantic analysis to perform following operations. The first one, matching of if-else statement. Second one, performing arithmetic operation that are type compatibility. Third one, checking the scope of operations. So in this slide, so we have an example. We have an example for sequence of tokens generated in lexical analyzer. The tokens are converted into syntax tree. In semantic analysis, this ID1, ID2, ID3 are declared into real. This numerical constant 60 is declared into integer. So here we face type compatibility error. So the semantic analysis to overcome this error into this numerical constant into real constant. Then next we move to intermediate code generator. Here the compiler translates the source program into intermediate representation, which is independent of the target machine. The two important properties of intermediate code, the first one, it should be easy to produce. Second one, easy to translate into target program. Intermediate form can be represented using three-address code. Three-address code consists of sequence of instructions which contain the maximum of 3 operand. So consider this example. The intermediate code generator phase to get the input from semantic analysis like this annotated parse tree and converted into the sequence of intermediate representation. That means this int to real is stored into temporary variable 1. This temporary variable 1 is multiplied with identifier 3. The result is stored into temporary variable 2. And third one, this temporary variable is added with identifier 2 and the result is stored into temporary variable 3. The temporary variable 3 is directly assigned into identifier 1. This is a sequence of intermediate representation. Then next we move to code optimization. Once we complete the intermediate code representation, the compiler enter into code optimization phase. The main goal of code optimization is to improve the performance either by reducing execution time or minimizing the memory usage without changing the output of the program. So in this slide, we have example. Already the intermediate code is generated. The T1 equal to int to real 60, T2 equal to ID3 into T1, T3 equal to T2 plus ID2, and next ID1 1 equal to T3. And the next we move to code optimization phase. Once we complete the intermediate code representation, the compiler enter into the code optimization phase. The main goal of code optimization is to improve the performance either by reducing execution time or minimizing the memory usage without changing the output of program. The above intermediate code is optimized into true line with the help of different optimization technique like constant folding, dead code elimination, common sub-expression elimination, and loop optimization. So we have so many methods of code optimization technique to optimize our intermediate code representation. Next, finally, we enter into code generation phase. The compiler produces the target machine code from code generation phase. The intermediate code instructions are translated into sequence of instructions like move f id 3, r2, multiplication f. F is indicating for floating point. Already we discussed in this example, id1, id2, id3 are declared into real number. So we indicate this real number in machine instruction is called f. Move f id3, r2, multiplication f. Number 16, r2, move f id2, r1, add f r2, r1. The finally move f r1, id1. That here r1, r2, these are all registers. That registers used in microprocessor or our processor. Next slide, the phase of compiler. This is a complete diagram of phase of compiler from lexical analysis to code generation phase. Our source program passes through the different phases of compiler to finally enter into target program. To summarize our slide, the first lexical analysis to break into tokens, syntax analysis, check the grammars, semantic analysis, check the meaning, intermediate code generation to produce machine independent intermediate representation, optimization phase to improve the efficiency, and final code generation phase to produce final machine code. The simple table and error handling phases. The simple table to store all identifiers with their type, scope of variable, and memory address. Error handling phase. This detecting the error in each phases. A compiler, therefore, not just a translator, it is an intelligent pipeline that gradually transforms a human readable program into optimized machine instruction. Thank you.